Welcome to the Hadoop Crash Course here at the Hadoop Summit. My name is Rafael and I am leading technical product marketing at Hortonworks. And with us is Ben and Dave, and they'll be helping also with the lab session. So let's get started. So, just to make sure the level set, this is an introduction into Hadoop. The idea is to kind of give you maybe about a half an hour lecture to kind of cover some key topics, set some context, and really spend the next 2 hours getting hands-on. So hopefully everybody has the VM. If you don't, raise your hand and we'll get it to you. And really what we're going to cover very quickly is why Hadoop, a little bit about the Hadoop ecosystem, focus on storing data and processing data, and the how to better utilize a distributed cluster, which is Yarn, right? Accessing the data and then kind of go into the lab. So I'm going to go kind of quickly. There'll be an opportunity to have more questions during the lab time. So let's keep you can ask questions, but kind of let's keep it limited so we can kind of go through the introduction content quickly, and then kind of move into the lab. And then the lab we can have a lot more discussion about some of the different topics. So with that, we're talking about a modern data architecture. People talk about Hadoop and potentially being this disruptive technology, but did Hadoop disrupt the data center? And really, what disrupted the data center is the data itself, right? And what's been happening with the data? So as we look at data, so I've been in the data space for over 15 years, and data has an intrinsic property that it grows. But what's happened is between the Internet of Things, social networks, the web content coming on board, there's been an inflection in the data, right? And that inflection has caused two things. One is the volume of the data has grown, and the variety of the data sets that you're dealing with has also sort of grown. So with that, traditional systems, in particular traditional business intelligence systems, analytic systems, have been under stress. That stress sort of comes in two fashions. One is economical, because the volume of data is going up. So now if you're trying to put those, load that data into the system, it can become cost prohibitive. And the other sort of main factor is that being able to scale those systems and consume the variety of data becomes challenging, and it becomes sort of a brittle system. It's not as agile, right? So with that came Hadoop, right? And if you've been following Hadoop, this can potentially be an R chart, and it can be overwhelming. I had one student that came during the Dev Cafe time and stopped by and says, "But where do I really start?" Right? So we're gonna net this down to something a little simpler. So instead of being overwhelmed by the potentially 19 plus Apache projects, I'm gonna start with sort of a little bit of a higher level. So what is Hadoop? So Hadoop is about distributed computing, right? So in sort of traditional analytic systems, you worked off one machine, right? And as you kind of want to scale that and deal with the challenges of the volume and the variety of the data, you start working with a collection of machines. We'll call that a cluster. And one of the key things that Hadoop does is it's a framework that provides a series of abstractions, right? So whereas if you're dealing with a virtual machine, it's you take one machine, you make it seem like multiple machines. So in the way you can think of Hadoop as the reverse, you're trying to take multiple machines and make it seem like one super machine, right? So in that we're going to create a series of abstractions. One is an abstractions around the disk drives in each of these individual machines, right? So there's a distributed, reliable storage system that deals with the individual file systems of these machines, and it creates an abstraction to make it seem like one file system across these machines. Now these machines are typically run Linux. They can run Windows, but they're commodity hardware machines, right? So they'll have their individual disk drive, CPU, and memory, and so we need an abstraction to kind of work with that. So the first one is this distributed reliable storage. And then we need a way to do computation across this cluster. So Hadoop provides a framework that does distributed computation, but the thing is that as you want to run multiple jobs, you need to figure out where the data is, how much load is on those machines, and kind of do sort of resource allocation across those machines. So you need a way to manage those machines and the resources of the machines. And we'll sort of generalize that into a data operating system, right? And then as you have these collection of machines and this distributed operating system, you want to be able to run multiple applications, right? And there's three sort of primary interfaces that you work with within Hadoop. So traditionally, and particularly as you think of Hadoop 1, you think of sort of a batch processing kind of system. And with the sort of innovations that have been happening with Yarn and Tez, now you're sort of having an interactive interface to this distributed environment. And lastly is a streaming interface, right? So where you have data that's, you want to do analytics on data as it's streaming, so it doesn't land on disk. Eventually it could land on disk, but doesn't have to land on disk, right? And with that, you have a series of data access engines. So you have these data access engines that can work with these different execution engines or interface to the data, and they can leverage multiple of them. You can switch between back and forth of them. And as you're looking at a data operating system, clearly, like any operating system, you have to deal with security. So you need a whole security sort of infrastructure to deal with that. And as you're looking at doing data processing in the enterprise, depending on the industry you are in, governance can become pretty important, right? Who's accessing it? When do they access it? What did they do with it? And why are we doing this? Because we're trying to build sort of applications. So another sort of view of that one picture with all the different projects in there is if we take that same picture, we can distribute the projects amongst that, right? So you can see the distributed file system. We call it Hdfs, the Hadoop distributed file system. And the data operating system, it's really a project called Yarn, right? That does the resource management. And then there's a whole collection of access engines, right? And today we're going to only focus on two of them, Pig and Hive, and we'll get a little bit more detail about that. And then there's ways to kind of get data in and do the governance. There's a series of projects that kind of do security. And the other thing you probably look at is operations, right? So operations is like, I want to manage this environment. I want to add data to it. So we're going to be using a tool called Hue to be able to do some of the processing. And to do the sort of administration of your cluster, there's a tool called Amari. So let's kind of take a closer look at our file system. So we said we have this distributed file system, and it kind of works. So we have HDFS. So you have this cluster. So if you look at that cluster, really running on that cluster, you have two things. You have a component for the distributed file system, and you have a component for your resource management, which is Yarn. So this is your worker node. This is those individual nodes that were spread across the cluster. And then on sort of a management node, you have this thing called the name node. So the name node and the data node are key components of your Hadoop distributable file system. So what's the difference between them? So think of your name node as sort of having the understanding of the cluster, of where the files are at, who has which files, right, and how to manage it in a reliable, distributed, reliable, fault-tolerant fashion. And we'll get a little bit into what that means. And then you have also sort of a resource manager that works on sort of a master environment. So if we take another view of that cluster and what that looks like, you have some management nodes where you have your name node and your resource manager, and then you have all these worker nodes. And in those worker nodes, you have the collection of the data node and the name node. And collectively, this is configured sort of as the core in Hadoop. So if we take another look at this Hadoop distributable file system, we mentioned that it was fault tolerant. So, and we mentioned that it's using Linux machines, and they're typically commodity machines. So I'm sure people here have how many person has had a hard drive fail on you, right? So if you're dealing with your personal machine, or if you're dealing with commodity hardware, having disk failure is typical. And as you're looking at a cluster in distributed computing, one of the things that this distributed framework did is provided an infrastructure for you to to deal with failures in your cluster environment. So one of the ways we do deal with failures in the distributed file system is that we have multiple copies. So part of the thing that Hadoop does is it has, by default, and you can configure this, but by default, it has three-way replication. So you add a file, and when you add a file into your environment, it automatically makes three copies of it. And it figures out how to distribute those copies across the cluster, right? And it has an algorithm to kind of do that. So let's kind of look at a little bit of an interaction between your name node and your data node, right? So the name node is again that service that understands where the file ends up and where the copies end up, and if a node goes down, figures out how to make another copy of that file. So there's constant communication between the name node and the data node. So hey, here's a heartbeat. Am I still there? And it figures out that hey, I need to add a copy of this particular file to data node 3, and it also knows where else that copy of the data is. So this is important for two things. It allows you to scale, but it also gives you multiple I/O, right? So it gives you better I/O because you have your file is available 3 times. So as you kind of doing your processing of your data, you have more sort of bandwidth to be able to scan through data at a more rapid pace. So now let's kind of go look into the sort of the processing, right? And typically in Hadoop 1, people thought of processing in Hadoop with the Mapreduce framework, right? And so it's a framework. So it provides an abstraction for you on how to deal with this computation across the cluster. It's been proven from gigabytes to terabytes to petabytes. It has a rich ecosystem around there. Now there's additional techniques that have evolved with Hadoop 2, and we'll kind of get to that. But sometimes there's some people that try to position that Mapreduce is dead. And as we look at a modern data architecture, you want to use the right tool for the right problem. So depending on what your problem is, batch processing might still be a good solution for what you're trying to accomplish. It can scale well, and there's already a rich ecosystem of tools that kind of can leverage that today. So let's take a little bit closer look at Mapreduce. So this concept of Mapreduce, what is it trying to do? You have this cluster, which is a great resource, and you have a lot of I/O and computation available to you. You want to be able to break down your problem into some discrete, smaller pieces to be able to distribute your problem across a cluster. So the map phase says, hey, this is a way I'm going to break down my problem. This is a data piece I'm going to work with, and it breaks down the problem across your cluster. And then there's the reduce phase, which does an aggregation. And oftentimes when you think of Mapreduce, there's this whole other notion of a shuffle, right? And what the shuffle does is, as I do some of the processing, I want to then move some of the data around so that I collate similar data together before I do an aggregation. So let's take another look at that. So I have a file called constitution. I add it into my cluster. It gets replicated 3 times across Hdfs. And the mapper kind of reads a file and understands it line by line. So what I'm actually trying to do is do a word count. So this is the classic hello world example that people often start with in Mapreduce. So I have a file, it has words in it, actually dealing with the constitution. And so I want to count how many words are there, how many words are there, unique words do they exist. So the file, the mapper kind of reads the file, right, and then reads it line by line. And it starts splitting the file so that we start identifying each individual word, right? And oftentimes when you think of, people talk about Mapreduce, they talk about this whole notion of key-value pairs, right? So in this case, each word is, the key, the value is how many times it exists, right? So it goes, and it can do this in parallel as it's broken across the cluster. So then there's a shuffle phase. So the shuffle phase is, how can we move that data around so that we can then get to an aggregation? So what the shuffle phase does is how many times did the word we or the exist, and let me kind of move all those existences together into sort of a larger sort of key value mapping. And the aggregation phase, as you can imagine, sort of sum these up, right? And this is, the general notion of Mapreduce. And so, Mapreduce is sort of classic in Hadoop 1, and it was focused sort of on batch processing. And as you sort of worked with this environment, you had it, what happened? So you had an environment where you had a very powerful tool that could do sort of large, big data sort of data processing, but it was focused on individual focused applications. So if you're trying to use your application to do clickstream analysis, and you have another application to better understand your customer, you would sort of build another cluster. But as you're dealing with big data, sometimes you want to share data across these different processing techniques. And also you want to better utilize this environment, because as you're dealing with a cluster, this could be hundreds of machines, and for every application, if you have to kind of create another 100 cluster environment, in some ways it's a big waste. So how can we better utilize this environment, right? And one of the things that happened as we went from Hadoop 1 to Hadoop 2 was how can we have better utilization of this environment? So the other challenge is that this Mapreduce batch-oriented environment, it's fantastic. And I love this whole idea of being able to leverage a cluster and these abstractions in a framework. Can we open that up to be able to use other techniques beyond sort of batch processing and open it up to other sort of data access engines? So with that, there was sort of some reaction, right? So we talked about the limitations with Hadoop 1. But it was good at managing the data, it scaled, it was cost effective, and it was open source. So, really what we need to do is, improve the utilization of it. And we talked about this whole notion of a data operating system. So in some ways, this follows, typical trends. So if we look at things like our operating systems that we use for our personal computing devices, there's something like Windows 3.1. It's like, okay, that was maybe a great operating system for what it was trying to do. And then there's iOS 6. But what do these two operating systems have in common, right? The thing that they have in common is that they're focused on a single application, right? So if you were on your Microsoft Windows machine and you're trying to listen to music and work on your spreadsheet, you had to choose which of the two you wanted to do, right? You really didn't have multitasking. And as Windows moved forward and the iOS moved forward, really the next step that operating system wanted to do was add multitasking to it, right? And in a similar fashion, our data operating system in Hadoop followed that trend. So we, instead of having a cluster that's focused on individual application, we want to have a multitasking operating system, right? So with that comes Hadoop 2. And then with Hadoop 2, one of the things that happened is Mapreduce was this framework where you had a computation framework that was how I do computation with it, but it also had it tightly coupled is how you allocate resources across a cluster. And what happened with Hadoop 2 is it decoupled that. So hey, let's make Mapreduce 2 and let's just focus on the computation aspect of it, and let's create a layer where we can focus on resource allocation, right? And the resource allocation layer is now Yarn. So now what Yarn enables is I can run multiple sort of execution engines, and I can run multiple applications on a single environment, and it'll figure out how to do the load balancing, understand what applications are there, do sort of fair resource allocation across those applications. And also sort of with this, as you look at Hadoop 2, there's this notion of TES, right? So TES is, you can think of it as more efficient processing for Mapreduce. It works very closely with Yarn. It was key in making Hive move from a batch-oriented to an interactive SQL environment. So one of the key things that happens as you look at Mapreduce, one of the key performance in Mapreduce in Hadoop 1, one of the key performance bottlenecks was that as you did a processing like a select statement, it doesn't translate to one Mapreduce job. It translates to a collection of Mapreduce jobs. And as you look at a collection of Mapreduce jobs, you have this, you have a map phase, a reduce phase, and then you write out to disk, right? And then you might do a map phase, a reduce phase, and then write out to disk. As you can imagine, the writing out to disk can become very cost prohibitive, right? I mean, it can really slow down your processing time. And so in order to optimize that, couldn't we do the Mapreduce, and the reduce without writing out to disk, right? And that's really the notion that TES brings, right? I'm still going to do that kind of processing, but instead of having intermediate steps where I have to write out to disk, I'm going to do it sort of all in memory, right? So we talked about this. I'm going to move along. So sort of to summarize, we have processing and storage. And that processing you can think of Mapreduce and Yarn as sort of the processing engine. You put TES there, and the storage is Hdfs, right? And this together makes core Hadoop. So now I want to move on to sort of how do I have my Hdfs, I have my Yarn, I have these processing engines. Now I want to start doing data access. So as we look at data access, I want to define a series of channels which I can access data, right? And I want to have my data in the data lake. So I want to have the data available to multiple data access engines. And I have different execution models, whether it's batch, interactive, and streams that I want to work with in the data. So this is the similar thing. So as we look at that large chart of projects in the ecosystem, many of them are focused around data access. And as you look at data access, this is sort of a breakdown and where they fall in. And as you can see, now you can use Hive in a batch environment, or you can use Hive in an interactive environment. Really, what changes there, or you can even do Pig in a similar fashion. And what happens there is you can change it, and it's like, do you want to use sort of the Mapreduce infrastructure with that, or do you want to use sort of TES with that? So, we talked a little bit about Mapreduce. So Mapreduce is this, it's a framework. It's in Java, and you have to start thinking in Mapreduce as how you do your particular algorithms. One of the nice things about SQL is that it's a declarative query language, right? You just tell it what you want, and the actual engine figures out what to do. So one of the ways that as people started looking at, how can we get more consumption of Hadoop, a series of abstractions layers were built on top of this sort of core technology. One of the first ones was this a technology called Pig, right? And Pig actually came from Yahoo. So Pig is actually a data processing engine. It has a language called Pig Latin, and it allows you to do transformations. It's a very simple language to kind of pick up, very focused on sort of the data processing aspects of it. So, as you work with Pig Latin, and in your lab you'll be working with Pig. So Pig is an abstraction on top of Mapreduce/TES. So it'll generate Mapreduce/TES and then work through the sort of the infrastructure. Each statement is processed by the Pig interpreter. If the statement is valid, it gets added to the logical plan. And when you actually work with Pig, none of the processing actually runs until you actually want to persist it in some fashion. So until you run the dump or store command, you actually kind of get to use it. So, in the lab, it's a pretty prescriptive lab. So we're going to kind of get you into the environment and get you to execute a Pig tool. What we're doing today, you can think of it as a potentially day-long, week-long course. The idea here is to kind of get you introduced, get you feeling and touching with it, to kind of get you some more solid foundation to kind of continue your learning experience. So here's an example of a Pig statement, and I'm trying to load data from 2 data sets, and I'm trying to figure out. Let's see. Oh, I'm trying to figure out what's my top 5 websites. So I have my users and I have a click stream, and I want to load those data, do a join, do some aggregation grouping, right, between those 2 data sets, do an ordering of clicks, and then I actually do the execution when I run the store command. So the other abstraction that started happening with this is, yes, Pig is nice, But really the lingua franca for many data processing workers or data workers is SQL, right? So can we have a SQL abstraction on top of Hadoop? And that's what Hive is. So Hive is a SQL abstraction on top of Hadoop. It's shipped with most distributions. It's proven to scale at petabytes. It has a broad and growing range of SQL semantics. And it's compatible with most of the BI tools. So in your lab, you'll have the opportunity to go actually do some processing with Excel. So we're going to connect from Excel to, or your favorite spreadsheet tool that has an ODC driver and connect to your distributed cluster and access the data. Okay? And Hive is actually originally developed by Facebook. Right? So we'll take a look at the architecture of Hive. So that, like many SQL processing engines, you have some CLI. We'll be dealing with Hue to kind of do the processing. There's drivers that you work with. There's a Hive server that manages the connections to the different clients, and there's a Hive engine that processes it. There's options in the compiler, so you can either use the Mapreduce compiler or the test compiler. There's an optimization steps and an execution. The metadata for many of this stuff in Hive is stored in a metastore, and that's associated with hcatalog. Right? And you can then Hive works on top of either Mapreduce or Tez across your data. You can choose which execution engine. So I'm just giving you an example. If you wanted to switch execution engines for your Hive environment, here's how you do it if you want to switch to Tez. Here's just sort of an example of the data types that are supported from a SQL perspective and some of the SQL semantics that are there. And also you can kind of see how it's been evolving, right? So we're currently at Hive 14 today. So there's more to be added, but it's rapidly evolving and growing. So at one point, Hive actually the query language it's called HQL, right? The Hive query language, and sometimes 2 years ago you could have thought of it as a very limited sort of SQL and not quite SQL, but it's really evolved. So it's pretty much anti-SQL compliant today. As you work with Hive, you want to work with it across your common data, and you have an option, whether you want to run it with sort of batch, or you want to run it interactive, leveraging something like Tez, and then this can work in conjunction with other sort of processing engines that you're working with in your cluster. And Hive and Pig can actually work together, right? So in the tutorial, you're actually going to do a little bit of Pig, a little bit of Hive, right? So you can use Pig to do some transformations on the data, and use Hive to do some of the querying on the data. So just an example. So I can take some raw data, put it into my file system, then I can do some transformation on the data, make it, clean up the data and make it into the format that I want, and then kind of continue to do sort of further analysis, right? And if once I kind of cleanse my data, done some initial sort of typical SQL analytics with it, I can then kind of move beyond that and do more advanced analytics like machine learning on that same data set, right? Leveraging multiple environments. So with that, now I kind of want to transition to the lab environment. The lab, did everyone receive the email with the lab document? Who didn't receive the email with the lab document? Okay, so there's a couple of folks that were added. Dave, can you collect the names of the folks who were added? So we'll get you the lab documents online. It's in a Google Doc, so we'll share it with you. It's going to deal with a logistics company that has a fleet of trucks, and they have, this fleet of trucks is kind of an Internet of Things environment where they're having sensors on these trucks that are not collecting additional data. And they want to identify two things. They want to find some of the truck data and figure out, what's the average mileage, and picking up from the sensors. And then they also want to calculate some risk factor for each driver, right? And the risk factor has, two main components: mileage and events, right? And they want to look at how much you're driving and what kind of events are happening. And if you're having more risk-oriented events, then you have a higher risk. We're going to work on this on the sandbox. So we'll check to see who has access to the sandbox. So you need the URL doc, and the high-level sort of scenario in the lab is there's some introduction to the technology. So, I'm often a believer. Sometimes you need to hear it, see it, touch it. So, you heard it through me. You're gonna read it. Have a repeat of some of the technologies. You can skim through that or read it a little more depending on how your learning method. And then we're gonna do it. So when you do it, what we're gonna do first is we're gonna get some data. We're gonna add it to our cluster, so it gets onto Hdfs. We're gonna do some querying on that data, and then we're gonna do additional processing. So we're gonna do some transformations with Pig, and at the end we'll do some more querying of that data. So that's the basic scenario. So before we move on to the lab, are there any questions?
Can we get a copy of your